Pair programming, when trust was built at one keyboard. Close your eyes for a second and picture a late 90s dev floor. Loud keyboards, big CRT monitors, and a strange sight if you were raised on one developer, one ticket. Two people are sitting at the same machine, sharing the same screen and somehow sharing the same mind. This wasn't a quirky office ritual. It was a deliberate practice that became one of the signature moves of extreme programming, and later the broader Agile story. And here's the twist. In the story we tell today, pair programming isn't mainly about typing speed. It's about what happens when software development stops being a solitary craft and becomes a social performance, when quality is something you bake in through dialogue, and trust is something you build through repetition. The reason this matters is that it reframes pair programming as a human technology, not just a technical one. There's a lovely historical echo here too. Martin Fowler points out that some of the earliest programmers, people like Gene Bardik, worked in pairs before pair programming even had a name, because they believed the best programs and designs come from two people who can critique each other in real time. Decades later, Kent Beck formalized the principle inside XP: write production code with two people at one machine. Pairing wasn't invented by Agile, but Agile gave it a home, a philosophy, and a reputation. Let's get really concrete because pair programming gets misunderstood. In the classic definition, two programmers work side by side at one computer on the same design, algorithm, code, or test, and they collaborate continuously. One is on the keyboard, the other is actively reviewing, thinking ahead, looking for defects, and questioning assumptions. The roles are deliberate and they rotate because the point isn't one person writes, one person watches. The point is shared cognition. The language you often hear is driver and navigator. The driver is hands-on, typing, making the next tiny step real. The navigator is eyes up, scanning for errors, holding the bigger intent, and nudging the pair away from dead ends. In practice, good pairs switch frequently because the switching isn't a politeness ritual. It's how you keep both brains engaged and prevent one person from becoming a passenger. This is why I like the rally car metaphor. The driver is handling the corners, the navigator is reading the roadbook and calling the turns. Alone you can drive, but you'll miss things, or you'll drive slower because you're also trying to navigate. Together you can push speed and reduce risk because you've distributed the work of thinking across two minds. That distributed thinking is not just a vibe, it's at the heart of how early pair programming advocates explain the benefits. Also, this matters for trust. Pair programming is not simply two people doing one person's job. In the early XP framing, it's closer to two people producing one integrated artifact. Williams and colleagues describe a pair as a unified unit that shares ownership of the work product, with both people equal, active participants throughout the session. That shared ownership changes the emotional tone of development. Blame gets harder, responsibility gets shared, and quality becomes a joint commitment. Now, the part that often gets repeated, sometimes too casually, is pairs produced better code and they didn't take longer. The truth is more interesting because the evidence is detailed, contextual, and occasionally messy. But the headline result in the early research era was remarkably consistent. Pairing tended to improve quality, and it often improved confidence and enjoyment as well. Start with John Nosek's 1998 field experiment, because it's one of the origin stories that gave pairing credibility beyond classrooms. Nosek ran a real-world study with 15 full-time system programmers at a program trading firm. They were asked to write a Unix script to run a database consistency check against Sybase, something none of them had done before, and they had 45 minutes. 5 people worked solo, 10 worked in 5 pairs. Nosek didn't just judge, did it work? He defined effectiveness using a combined score including readability and functionality, and used multiple graders with high inter-grader reliability. The results: the paired teams outperformed the individuals on the overall score and the functionality measures, and they reported higher enjoyment and greater confidence. Even the framing is revealing. Nosek calls out that the surprise wasn't only to management but to participants themselves. The teams were better, happier, and more confident. What about speed? Nosek's data showed the individuals took, on average, about 41% longer than the pairs, around 42.6 minutes versus 30.2 minutes, although the time difference wasn't statistically supported in his small sample. That detail is important. The experiment points in the direction of faster completion for pairs, but it's careful about what can and can't be claimed with a small n still. The quality and confidence differences were statistically significant in his reported results. 2 years later, Laurie Williams and colleagues published Strengthening the Case for Pair Programming in IEE Software, and that paper became one of the most cited pairing-era texts inside the Agile world. It doesn't just evangelize, it collects anecdotal experience, describes the practice in detail, and reports structured experimental results. It also explicitly summarizes Nosek's study in a way that became part of the folk memory of Agile. Pairs completed the task faster and produced better algorithms and code. Williams et al. Also ran a controlled university experiment at the University of Utah with senior software engineering students. Students completed 4 assignments over 6 weeks, and the researchers compared individuals versus pairs. The pairs consistently passed more automated post-development test cases. The differences weren't subtle, they were statistically significant, and the table in the paper makes the point visually. Across all programs, pairs beat individuals on test case success. There's another detail in that paper that's almost more important than the test case numbers: the behavioral observation. Some individuals didn't hand in work or submitted late, while pairs handed in on time. The authors attribute this to the positive pressure of not wanting to let your partner down. Pairs said they worked harder and smarter because someone else was counting on them. That's a quality result, yes, but it's also a social result. Accountability and follow-through emerging from relationship, not management metrics. If you've ever wondered why XP people talked about pairing with almost moral energy, read the pair satisfaction parts of the early literature. Williams and colleagues report that in an online survey of professional pair programmers, 96% said they enjoyed their job more than when they programmed alone. In their student experiment, over 90% consistently reported they enjoyed collaborative programming more than solo programming, and almost 95% echoed that they had more confidence in their work. That's not soft fluff, that's directly connected to reducing uncertainty and reducing the emotional cost of problem solving. Another early piece that often gets quoted is Cockburn and Williams' Summary of Costs and Benefits. Their headline is blunt: pair programming has a development time cost, often described as about 15%, but it improves design quality, reduces defects, reduces staffing risk, enhances technical skills, improves team communication, and is considered more enjoyable at statistically significant levels in their reported research. That list is basically the blueprint of why early Agile cared. Pairing makes quality, continuity, learning, and communication stronger. So how does pairing actually teach? Not in the formal training course sense, but in that quiet, continuous way where you get better every day because someone is beside you. One answer is that pairing forces articulation. When you're the driver, you're almost compelled to narrate, "Here, that's what I'm doing, here's why." When you're the navigator, you're compelled to ask, "What assumption are we making? And what if we tried the other way?" That narration is a learning engine because it externalizes thinking and makes it correctable. We can point to research on knowledge transfer mechanisms directly. Ziris and Pritchett, analyzing recordings of industrial pair programming sessions, argue that knowledge transfer isn't a side dish, it's one of the dominant modes of what pairs do. They treat it as unavoidable because partners constantly explain their thoughts and ideas to each other, and they show that some pairs are far more effective than others at transferring knowledge efficiently. The detail matters. The skill isn't just knowing software, it's knowing how to explain one thing at a time, clarify in stages, and maintain common ground. That pairing is a skill point is crucial if you want a realistic picture. A lot of the early controlled experiments on pairing produced variable results, and Ziris and Pritchett suggest a reason. Studies often measure software development skill but ignore pair programming skill, how well people collaborate, communicate, and exchange knowledge under pressure. This gets us closer to the lived truth. Pairing isn't automatically good. It becomes good when people learn how to do it well. Now let's talk novices, because your segment mentions the learning boost for less experienced programmers. In education research, pair programming has consistently been investigated as a way to help students progress faster and stay engaged. McDowell and colleagues, in a Communications of the ACM article, studied intro programming students and examined performance and persistence. That paper is widely cited in computing education discussions because it links pairing not only to program quality, but to confidence and retention. Step up a level. The systematic literature review by Saleh, Mendes, and Grundy looked across a large body of higher education studies and synthesized evidence about effectiveness. They report that student satisfaction when pairing is overall higher than when working solo, and their meta-analyses show pair programming can be effective in improving assignment grades. They also identify that student skill level is a major factor influencing effectiveness, meaning the benefits are not uniform, but they often show up strongly depending on who is pairing and how. And this is where the two average people can handle a more difficult problem. Idea becomes more than a motivational poster. Williams and colleagues cite research on feedback and idea exchange decreasing the probability of proceeding with a bad design, and they emphasize that collaborators can often perform work too challenging for one person alone. Pairing works partly because it pools attention. While one person executes, the other can hold the structure, catch inconsistencies, and prevent tunnel vision. The result is not just faster output, it's fewer wrong turns. Let's name the thing we rarely say out loud in engineering culture. Software quality depends on trust. You have to trust the code base enough to change it. You have to trust your teammates enough to merge their work. You have to trust that you won't be punished for asking dumb questions, and that someone will catch you before you ship a subtle defect. Pair programming in the XP era was one of the most direct ways to manufacture that trust through daily ritual. There's an academic framing that makes this explicit. A paper contrasting agile and Tayloristic approaches talks about trust and care as central to knowledge sharing. It argues that software development is a social process and that building organizational and individual trust matters, because trusting other people and their code facilitates reuse and more efficient knowledge sharing. It then names specific Agile XP practices, collective code ownership, stand-ups on-site customer, and pair programming as mechanisms that promote mutual trust, respect, and care among developers. That's a strong claim, and it's worth interpreting carefully. The paper isn't saying pairing magically makes people nice. It's saying the structure of the work creates more opportunities for voluntary interaction, and that those interactions are the conduit for trust. Pair programming is dense interaction. You're exposed, you're collaborating, you're negotiating, you're being corrected, and you're correcting back. Over time, that repeated experience trains your nervous system. It's safe to think aloud here. Notice what early pair programming authors emphasized about enjoyment and confidence. In Williams et al., the argument isn't just pairs write better code. It's pairs feel better doing it, and that feeling is tethered to confidence. Someone is there when you're confused, someone can sanity check your thinking, someone can help you explore alternatives. That kind of support changes how you behave in complex problem solving. Less panic, more curiosity, more resilience. And there's another trust outcome people don't always value until it's missing: staffing risk. Even the early cost-benefit summaries emphasize that pairing reduces staffing risk because knowledge isn't trapped in one person's head. When two people share the work, two people learn the work. That's not just redundancy, it's continuity, and continuity is what keeps systems alive when someone goes on leave, resigns, or simply has a bad week. If we zoom all the way out, pair programming is basically an anti-fragility mechanism for teams. It spreads knowledge, it normalizes critique, and it makes the code base feel like a shared public space rather than a set of private territories. In modern language, we might call this collective ownership, but in practice the glue is trust. I trust you to touch my code, and I trust myself to learn from you when you do. Now, if we're going to be honest, and a good podcast is honest, we have to address the pushback that pairing has always had. Pair programming looks wasteful at first glance, and even early authors acknowledge that. Two people at one keyboard triggers the manager's reflex. That's two salaries for one output. In the literature, that objection isn't dismissed, it's tested. The evidence suggests the cost is real but not linear. Cockburn and Williams talk about a development time cost, often described around 15%, but also list a suite of benefits that matter economically: better design quality, fewer defects, improved communication, reduced staffing risk. Williams et al. Explicitly argue that pre-release programmer hours do not simply double, and they show contexts where pairs are faster and produce better results. The argument is you're buying fewer defects and fewer wrong turns, not paying double for the same thing. Meta-analysis reinforces that context matters. Haney and colleagues synthesized published experiments and concluded pair programming is not uniformly beneficial or effective, with high variance across studies. They also report a more conditional pattern. Pairing tends to be faster than solo work when task complexity is low, and it tends to yield higher quality solutions when complexity is high, often at the price of greater effort. That's an important corrective to simplistic folklore. Pairing isn't a universal speed spell, it's a trade-off tool, and there's a human nuance too. Pairing can fail socially. Williams et al. explicitly describe dysfunctions: too much ego, my way or the highway, or too little ego difficulty asserting ideas, and they note that many participants in early studies were self-selected pair programmers. In other words, people who already liked pairing were overrepresented in some of the early data, which means adoption in the wild requires skill building and careful culture work. This is where the concept of pairing as a teachable skill becomes essential. Ziris and Perchelt's work suggests that what varies across pairs isn't only technical competence, it's how well partners identify knowledge needs and move information back and forth constructively. If you want the benefits of pairing, you don't just assign pairs, you coach behaviors, how to explain, how to ask, how to switch roles, and how to keep the conversation focused. So why spend all this time on a practice from the XP era? Because pair programming wasn't merely a procedure, it was a philosophy about how software gets made. It said, truth emerges through dialogue, quality emerges through feedback, learning emerges through shared effort, and trust emerges through repeated collaboration. And once you've seen software built that way, you start noticing how many modern development habits quietly remove those ingredients. Pair programming at its best was an antidote to what I'll call private development. Private development is when you treat your work as a hidden process and reveal only the finished artifact, the pull request, the ticket, the demo. Pairing flips that, the process becomes public in real time, where mistakes are caught earlier and ideas are tested faster. It's not just a way of coding, it's a way of being seen. And when you're seen, you change, you practice diplomacy, you practice explaining. You practice taking critique without collapsing into defensiveness. You practice what teams depend on when systems get complex and stakes get high, the ability to think together without ego making it unsafe. In that sense, pairing built social muscles that are easy to lose when work becomes individualized and asynchronous. I want to underline one last detail from the early results: enjoyment and confidence. It's tempting to ignore those as soft, but they're not. Enjoyment is a proxy for sustainable practice, and confidence is a proxy for decision-making speed under uncertainty. When early studies report that pairs felt more confident and enjoyed the process more, they're hinting at something deep. Pairing reduces the psychological load of complexity by sharing it. So here's where I'll leave you, not with a conclusion but with a set of questions, because the XP era gave us a mirror, and mirrors are meant to be stared into. If pair programming was partly a trust machine, an everyday ritual that built mutual respect, shared ownership, and continuous learning, what happens when you remove it from your culture? If pairing is a teachable skill, as later research suggests, have we treated it like a skill, or have we treated it like a preference? If we train developers to pair as deliberately as we train them to write tests, would our teams behave differently under pressure? Would we ship fewer defects, or would we simply argue better? And this one is personal. When was the last time you built trust by solving a problem with someone in real time with nowhere to hide, just a shared screen and a shared goal? Did it make you faster, or did it make you better? And if it made you better, what have you replaced that experience with in the way you work today?